Okay, last section we did the side, side, side postulate, where all three sides are congruent to the other three sides of a triangle. And then we also did the side angle side, where the angle in between the two sides that are congruent. So today we're doing angle side angle, which the side is between the two angles that are congruent. So if you know that this angle, these two angles are congruent right here, and we know that these two angles are congruent right here, and we also know that the side in between them is congruent, then the other two sides and angle have to be congruent. And same with angle, angle side. It is, you have two triangles, and you have an angle, angle, and an angle, and the side is not in between. So it could either be the red side, or it could be the other side that is equal. And as soon as you know that the side and the angle that's not included, they are congruent, then you can say the two triangles are congruent. So when we're doing a proof, we still start out with the given. So I'm going to write down the given. Okay, so I wrote down the two givens. Now I'm going to mark them. Always mark your givens and see what you can do with it. So angle A is congruent to angle B. I marked it. And then I have the side AP is congruent to the side BP. And I marked it. Okay, so then I look at these two lines. Is there anything else that I can do with these two lines? Is there transitive property going on, or substitution? And there's not. So now I gotta look at my diagram. Is anything else going in the diagram? That any sides or angles, do they share the same side? Is there reflexive property going on? There's not. So the other thing I can look at is vertical angles. Remember I said vertical angles are the easiest thing to mark. So these two angles are congruent. So I'm going to write in angle YPB is congruent to angle APX by the vertical angle theorem. So now I check, do I have side, side, side? No. Do I have side, angle, side? No. Do I have angle, side, angle? Yes, because the side is in between the two angles. The side is in between the two angles. So I go up here and copy down the triangle proof, or triangle congruent statement. Triangle APX is congruent to triangle BPY by the angle side angle theorem. Okay, for the next proof I wrote down my givens, so now I'm going to mark them on a diagram. So if I know that angle B is congruent to angle D, and I know that, actually this shouldn't say congruent, it should say parallel. So AB is parallel to CD. Okay, so if anything, is there anything from that I can conclude? Well, I can't really do anything else with angle B is congruent to angle D, but I can do something with parallel lines. So if I look right here, if these two lines are parallel, I actually have three transversal, this, this, and this. So I'm going to work with AC as my transversal. So I have alternate interior angles inside here, so I'm going to mark that this angle is congruent to this angle. I can't call it angle A and angle C because I don't know what angle A would be. Would it be this big thing? Would it be part of it? So I'm going to say that angle BAC is congruent to angle ACD by the alternate interior angles theorem, which says that if you're given two parallel lines, which I was right here, and you have a transversal, the alternate interior angles are congruent. So I have two angles that are congruent. I don't have any sides yet, and I know I need to have a side, but I do have the same side right here. They share a side. So I know that AC is congruent to AC, I'm going to mark it, by reflexive. So now I have enough to say the two triangles are congruent because I have an angle, and a side that's not included between the two angles. So I'm going to copy this statement right here, triangle ABC is congruent to triangle CDA by angle, angle, side. Because angles A, or the vertex A, corresponds with C. A corresponds with C, B corresponds with D, and C corresponds with A. Over here, this A and that C, right there. Okay, next one I'm going to write my given. Okay, I wrote the two givens, now I'm going to mark them. So angle S is congruent to angle Q. The ray RP bisects SQR. So remember, if a ray bisects an angle, that creates two congruent angles. So these two angles have to be congruent. So now I need to write that they're congruent. So angle QRP is congruent to angle SRP by the definition of angle bisector. So I've used all my givens, so now I have to look at my diagram. Are there any vertical angles? Are there sides that are in common? Are there parallel lines that are going to create angles? So if I look, they share the same side. So that means that PR has to be congruent to PR by reflexive. So then I have two angles and a side that's not included. So I can say that triangle SRP is congruent to triangle QRP by angle, angle, side. Alright, I do the triangles for 4 and 5 because I think it helps. 4 says which side is included between angle R and angle F. So here's angle R, here's angle F. The side that's between them is the segment RF. And the angles between US is if I highlight US. The two angles are angle U and angle S. Number 6, tell whether that you can prove the triangles are congruent. Some might not be possible. If you can, state the triangle postulate theorem that you would use. So, if I look, this one has an angle that matches up with this angle. And then H matches up with Q. And then there's a side that's not included between them. So I can say that they're congruent. So I could say triangle GHI is congruent to triangle. Now you want to be really careful. So G matches up with P because they both have those one arcs right here. This is one arc, this is one arc. So if I wrote G first, I need to write P. And then H matches up with Q, so I'm going to write Q. And then R and I both don't have anything on it, so that's going to be R. So that's how I want you to write the triangle congruent statement. So this is by angle, angle, side. And then letter B, this means that they're parallel right here, these arrows. So I'm going to mark, I know that this is congruent to this because they're alternate interior angles. And I also know they share a side length right here. AP is congruent to AP. So I only have an angle and a side, so I don't have any other information. So I can just write not possible. I would need to have either another angle or I'd have to have the side, these two sides would have to be congruent because it would have to be the side or the angle that is between two sides. So it's I can't do anything. Okay, here's some more to mark. So right now I have angle, angle for letter C, but I do know that they include a side. So I have an angle, angle, side. So I can write triangle ABX is congruent to triangle. Now A And this triangle corresponds with this triangle, or this angle right here, because they both have one arc. So I'm going to write A. And then the B corresponds with angle C. So I write C, and then X is X. And this is by the angle, angle, side. So then the next one, I have a side in between two angles. And a side in between two angles. So I can say that triangle ABC is congruent to, now A matches up with F. A matches up with E. And then B doesn't have any marking, so that matches up with D. And C and F both have the double marking, so that's F. And this is by the angle, side, angle. And then E, I have two angles. I don't see that they share a common side. There's no other markings that have those tick marks. But I do see that by vertical angles, these two are congruent. So this would be three angles. We do not have an angle, angle, angle. So there's nothing that you can conclude. And then the last one, F, I can mark the reflexive property. XY is congruent to XY. So now I have a side, angle, side, because the angle is between the two sides that are congruent. So I can say triangle WXY is congruent to triangle. W matches up with Z. X and X both have one hash mark, so it's X, and then Y. And this is by the side, angle, side. So far we have four side, 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 angle, side, angle, side, angle, and angle, angle, side. The one that we don't have is SSA, or if you remember it, it's a naughty word backwards, so we don't have this one. The other combinations we have though. We also don't have angle, 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 because you could draw something. You could have an equilateral triangle with 60 degrees and another equilateral triangle with all 60s, and they're not congruent. They're similar, but they're not congruent.